Good day everyone. In this video, I would like to talk to you about Numerical Analysis Challenge 2. In this challenge, I will delve into the intricacies of the LU decomposition, particularly its recursive implementation, and explore a multi-level generalization of this approach in Julia, and I will explain how it works in this presentation. Firstly, the code begins by importing three Julia packages: double floats, linear algebra, and benchmark tools. Double floats is likely used for creating matrices with higher precision floating point numbers, while linear algebra is used for some basic linear algebra operations. Benchmark tools is used for benchmarking code performance. Next, the code allows you to specify the dimensions of the random square matrix by setting the variables n and m. It's important to note that n and m are both set to 2 in the provided code, so it generates a 2x2 random square matrix by default. You can change these values as needed to generate matrices of different sizes. Moving on, there are different approaches to decomposing matrices, such as standard LU decomposition, recursive LU decomposition, and multilevel decomposition. Each of these methods has its own advantages and disadvantages, which are discussed in the report. Standard LU decomposition is a direct method that factors a matrix into a lower triangular matrix and an upper triangular matrix. It is simple and easy to implement, but it can be computationally expensive, especially for large matrices. Recursive LU decomposition, on the other hand, divides the matrix into smaller submatrices and recursively applies LU decomposition to them, combining the results. It is a divide-and-conquer approach that can be more efficient for larger matrices by taking advantage of parallelism and reducing fill-in. It can also be adapted for sparse matrices, making it more memory efficient. Finally, multilevel decomposition is a hybrid method that combines the advantages of both standard and recursive LU decomposition. It is a more complex method that requires more computational resources, but it can be more efficient for certain types of matrices. In conclusion, generating random square matrices using Julia packages is a useful tool for various mathematical and numerical computations. By understanding the different approaches to decomposing matrices, we can choose the most appropriate method for our specific needs. Thank you for listening.